Hello everyone. In this lesson we're going to look at how we collect and organize data and keep it in a nice neat fashion so that we can actually draw conclusions from it. Now that means we're going to be making measurements and we're going to be recording those measurements in tables. Now when you make a measurement it's important to be precise. Precise means you measure as close as you can with the instrument you have. So if you have two lines that are a little bit distance apart and you want to measure between them, your ruler will have a scale on it, and it'll be a graduated scale, and it might have major marks, and then it might have minor marks, and then it might have a major mark. If you're looking right here, if this is 1 and this is 2 and there's 10 of these little marks in between, then this is more than 1.9 and less than 2, so you might say 1.96. So you've got to measure as close as you can with the tool that you have. The tool is what determines how precise or exact your measurement can be. So a ruler can measure to the closest hundredth of a centimeter, right? You can go to the closest millimeter, which is a tenth of a centimeter, and then you can estimate one more place if it's between two lines. So 1.2 grams is less precise than 1.23 grams because we're saying to what degree we know information. So record the correct precision based on your device. Smaller fraction means it's more precise. Then it's also important to be accurate, which means we've got to make sure that if this is the 0 mark right here, we don't start measuring from the edge of it there. So use your tool correctly as well. And accurate means how close to correct you are. Precise means how exact you are. So make sure you're using and measuring carefully, and that if you're using something that has to be calibrated before you use it, like a balance or a scale, that you make sure that they read 0 when there's 0 mass or force applied to it. And then to reduce errors, we do multiple trials, because if we do one trial, there's some uncertainty in that measure. If we do a second and the two are very, very far apart, we've got an idea that something bad happened, so we do at least 3 trials with each measurement so we can make sure we're getting consistent, repeatable, precise results. Now, once you have your measurements, you need to record them somewhere so you can do something with them, and that's what a data table is for. And you will have to set up a data table. It should have a title and clearly labeled rows and columns. Your title is like what the data is you're collecting, and then your rows and columns are going to have the information. Your columns are going to be the variables. The first column is the independent variable. Remember, columns are vertical. They go up and down. Rows go side to side. The next 3 columns in a data table are typically for your dependent variables. You'll have multiple trials, so you'll do the same measurement 3 times, and then we need an average of it. So 3 columns are for multiple trials of the dependent variable, and the last column we will average those trial values together because our result is somewhere in between them. And remember, to find an average, you add up all of the numbers that you have and divide by how many numbers that you have. And then you should round your final answer so it has the same number of decimal places as what you measured. If you want a better rule than that, take more signs. Now, different rows are for the changes you make to the independent variable. So row 1 is going to be multiple things of the same trial. Row 2 is multiple things second trial, or the change in your independent variable. So if we take a look, here is an example data table. I have the independent variable over here. Now you won't write unit, you'll write whatever unit you're measuring in. So that could be centimeters, that could be kilograms, that could be seconds, whatever your independent variable happens to be. And over here I would have the dependent variable with its unit, and I would have that for trial 1 and trial 2 and trial 3. So if I'm going to change the length of something, I would say length, and this could be 12 centimeters, and I would do 1, 2, 3 trials, and that might be measuring time, and then I would find the average. Now, what does this actually look like in Google Sheets? Well, I'll show you how to set that up in just a second. Okay. Once you have this data, you're going to graph it and you're going to draw conclusions from it. So here's some example data. I've got age in years, and I've got shoe size for person 1, person 2, person 3. So I'm looking if there's a relationship between how old somebody is and what size shoe they wear. And I've only got a 3-person sample size, and so I've got this data. Now what's cool about this is you can have Sheets do this for you. Let's take a look. So I went ahead and I put this data into Sheets, and I've got my heading still. I've got my age in years, I've got my shoe size for person 1, shoe size for person 2, shoe size for person 3. And now I need the average. So what's the average shoe size of somebody who's 8 years old? And Sheets will do this for you. If you type equals, it'll give you a formula, and then I can type a parenthesis, and it's like, all right, what formula do you want? I want, whoops, not a parenthesis, I want the formula. So equals, and I'm going to start typing average, and it pops up right there. There it is, average, and it says, okay, this is going to find the average of whatever data that you tell it. So I want it to average the shoe sizes for these 3 people, and then I close my parenthesis and I push enter, and it does that for me. And now I can drag that formula down through that column, and it finds all of the averages for me. But I'm only measuring to the closest half place. I don't really care if you do this, but I'm going to say only show my precision to 1 decimal point. And I did that by clicking up here, and so now I can see my average shoe size. So Sheets went ahead and calculated the average for me, and I could copy and paste this table into my lab report. Alright, so I have my lab or my data table set up. I've got my data in there. Now what? Well, I collected that data because I want to draw conclusions. And I can see, looking at my data table, that as the age increases, so does the average shoe size up to a point. But I have to look at a lot of numbers to see that. So a graph is actually going to help us see that better. So that visual representation of data is the purpose of a graph. And we can quickly see relationships between variables. And again, you scale it and label it so the information that you're after is clear. Scale means you put numbers on the x-axis and the y-axis, and label means you give those axes titles so that we know what we're looking at. And your graph should have a title as well. We'll use line graphs or scatter plots extensively in here because they show relationships between 2 variables. Sometimes I'll show you how to do that with Sheets, but you've got to be careful. Sheets sometimes picks a goofy graph. Okay, so the horizontal axis, that's the one on the bottom, that's always going to be your independent variable. So down here we have our independent. Over here on the y-axis we will have our dependent. Right? So independent at the bottom, dependent on the side, and then we can see the relationship between them. So let's take a look at how to do that. Well, first how to sketch it, and then how to do that in Sheets. So if I'm sketching this, I can see I've got to get a years from 8 to 20, and I've got 1, 2, 3, 4, 5, 6, 7. So if I start right here at 8, I can go 8, 10, 12, and I'm keeping my scale constant, 14, 16, 18, 20, 22. I always counted by 2. I didn't start at 0. Sometimes I want to, sometimes I don't. On this, I've got to get from 6 to 10 and a half. I've got lots of spaces, so I'm going to go 6, 7, 8, 9, 10, and that 10 and a half is going to be up there, so I'm going to extend my graph, and I'm going to put it out up here. And so you can see on this scale, I counted by halves. So there's 6.5, 7.5, 8.5, 9.5, and 10.5. And so now I can plot this stuff. So if I'm 8 years old, I have an average shoe size of 6. 10-year-olds have an average shoe size of 7.5. 12-year-olds have an average shoe size of 9. So I'm just going to my age, which I should put here. And this is in years. I should put my unit there. And over here I have shoe size, and this is the US shoe size, so that's actually my unit. And then my title would be age and shoe size. Okay, and so then I can do 14 years old is 10 and a half, so that's up here. And 16 years old is 10 and a half, and 18 years old is 10 and a half, and 20 years old is 10 and a half. So we see this trend where the shoe size increases and then flatlines. Okay? So that's sketching it, and it's a perfectly okay way to do things, but your computer, your Chromebook, Google Sheets can do this as well. So let's take a look at how to do that. So here's that data that I had, and I'm back in Sheets, and now I'm going to select all of the data that I want to chart from or a graph from. And I'm going to go Insert, and then I'm going to say Chart. Now, Google automatically picked this goofy bar chart, column chart, that I don't want, doesn't mean anything to me. I want a scatter plot. And I actually don't need a scatter plot of every single person's shoe size. Instead, all I need is the average shoe size. That's why we calculated the average. So I'm going to go ahead and remove everything except that average. And now you can see here's the same trend line that I had before. I do want to title this graph, so I can do that. Chart axes and titles. So the title of the chart, we're going to go with shoe size versus age. So once I have the chart title, then I can click this to the horizontal axis, and the horizontal axis is age in years. And then I can go to the vertical axis, and this is shoe size, and that's US shoe sizes. So now I have my data table, I have my graph, I can see my relationship, and I could put that in my lab write-up.